Hello, welcome to this course. This course is about TypeScript basics. TypeScript is superset of JavaScript, or you can say it takes JavaScript to the next level. With this course, you will learn less clean and better code and exciting new features. Course plan. We will begin understanding what is and why to use TypeScript. Then we will set up our environment. Then we will learn some core concepts. Variable declarations, variable types, functions, arrow functions, interface, classes, object, access modifiers. Let's begin first. What is TypeScript? TypeScript is object-oriented and open-source programming language developed and maintained by Microsoft. Object-oriented means it deals with real world. By open source, it means it's freely available. It's typed superset of JavaScript. Superset means adding new features and adding advantages to JavaScript. TypeScript is a programming language and tool. It compiles or transpiles to JavaScript. If it compiles to JavaScript, then why transcript? Because browser understands only JavaScript. Then why TypeScript? TypeScript extended JavaScript, and there are many benefits of using TypeScript over JavaScript and over CoffeeScript and Dart programming languages. TypeScript supports object-oriented programming concepts like classes, interfaces, inheritance, etc. It's open source. It's strongly typed superset of JavaScript. JavaScript don't know what the type of variable is. That makes further problem while runtime. On the other hand, the type of variable declared with no type in TypeScript may be inferred by the TypeScript based on its value. That will help in compile time. TypeScript has IDE support. TypeScript is main programming language for Angular, and it's also used by Vue and React.js. Features are constantly improved by Microsoft, so it has rapid growth and use in future. Considering all these reasons, so it's a good time to learn TypeScript. Before we get started, we need to set up our environment. To start typing TypeScript code, we need to set up our development environment. First, download and install Node.js. Go to nodejs.org. Download and install latest stable release. Then open command prompt, type node-v. You can see the version of installed Node.js. To install TypeScript, run the command npm install -g TypeScript. This will install TypeScript globally. To check the version of TypeScript, write the command tsc-v. You can see the version of TypeScript. We need editor to write code. I am using Visual Studio Code. To download, go to code.visualstudio.com. Now we are all set to start typing TypeScript code. Let's start by writing a Hello World program. Open Visual Studio Code, create a folder, create your first TypeScript file. You can give any name with .ts as extension. TS is the extension of TypeScript. I'm going to declare a new variable that will hold the value of our message. Then log on to the console, write console.log message. Next, we have to compile this down to plain JavaScript using TypeScript compiler. Open terminal and run the command tsc first.ts, that's the file name. Command creates the file first.js, which contains transpiled code. To run the program, run command node and the file name. You can see the output hello world. So that's your first TypeScript code. You can see the JavaScript code. You can notice this red line, that's error. If I hover, it says cannot redeclare block scope variable message, because this file is treated as script, not as module, because script has global scope. Let is having local scope. To solve this error, we can add export statement at the top by declaring import or export. TypeScript treat this file as module instead of script. You can see error disappears and change is reflected in the JS file as well. Now we will learn how to declare a variable and different types and some of the things we can do with types. Let's sum a variable. Sum is equals to 100. Sum is equals to a string, that is ABC, and then a boolean true. These are all valid JavaScript. JavaScript don't care any value to any variable because there is no concept of types. But what if we want typing that? But what if we want that variable to be a number only? And we don't want any other value assigned to it? No problem. We can do that by declaring a variable with a number. This is the typing concept in TypeScript. That's why TypeScript is a typed superscript of JavaScript. We can declare a variable with type in TypeScript, so this tells TypeScript that is only a number. Now you can see ABC is a string that is not assignable to a type number. And true is a boolean value. Again, it's not assignable to type number. The pop-up you have seen is the intelligence support that Visual Studio offers. Now let's see what are the types that TypeScript offers. Let's first see built-in types. Let A a number 10, B string, C a boolean, true, let D any. Any is the super type of all data types. You can see we can assign D as a number also, a boolean value also. But C as a boolean value cannot have 9 as a number. We have array. Let's see. We have array. Let's declare array with a number. We can optionally initialize the values. Array like this. We can also have array type as any. We can set any values to this array. We have undefined denotes value given to all uninitialized variables. Null represents an intentional absence of an object value. We can have array of different types. TypeScript provides a tuple type. For example, let's create a tuple that contains a string and a number. Let's have amp and type string as a name and number as its age. Number of elements in this tuple is fixed. We can't give third element as it is declared with 2 elements. We have enum. We can put all the related constants in the enum. We can declare enum like this, giving name as a color and the values in the curly braces. Orange, yellow, green. Then we can declare a variable to see the values. In enum, First element automatically gets the value as 0. We can see the value. Let's run the code and log the value of green. You can say it's 2. Orange as 0, yellow as 1, green as 2. Each subsequent element has a incremental value. So we don't have to explicitly set this. But for the better practice, you can do so. If we are setting the value of orange as 5, as the subsequent elements are incrementing its value, you can see green as 7. We have const. Const is once assigned can never be reassigned. Const value must be initialized. These are the built-in and user-defined types. Other user-defined types, classes, interfaces are coming next. Moving on to functions. Functions. Now we will take a look how functions work in TypeScript. A function is a set of statements to perform a specific task. Let's create a simple function, add nums that will add two numbers. It takes two parameters, num1 and num2, and return num1 plus num2. We can see the value returned by the function. It's working fine. But when I try to pass only one value, it throws error. An argument for num2 was not provided. If I try to give second parameter as a string, it's also fine. Because addNums function requires two parameters, irrespective of its types. We can see the value returned by the addNum functions, that's 5 string. So to make it meaningful, this is how you can see functions in JavaScript. In TypeScript, we can specify types or function parameters. So we can have num1 of type number and num2 as type number. Now you can see it throws error. Type string is not assignable to parameter of type number. This is the power of types. We can assign types to return types of the function also. That is about using types with functions. TypeScript has also other features when it comes to functions. In JavaScript, we can return a function with one parameter also. We can do that in TypeScript also by adding question mark to the end of parameter, making it as optional. For example, if we want num2 as a optional, we can add question mark to the num2. You can notice add nums with only 5 as a parameters gives no errors. We can also set parameter as default. By removing the question mark, we can set the value of a parameter. If we are not passing that value, it will take as default that value. You can see the results. Second time we are not passing any value and it is taking num2 as default, that is giving 15. I will also show you how we can use arrow functions in TypeScript. In TypeScript, you can use arrow functions to keep your code clean. That can also avoid problem with this. Instead of typing function and the brackets, use just brackets and then fat arrow to signify it's a function. And that's it. And instead of function name, we can store the value of function in a variable. We can use const as the value of function. Returned value of function will remain constant. You can see the results same as functions is giving. With this, we can conclude with functions. Interface. TypeScript also has a concept of interfaces, which let you define the template for an object. An interface is defined with the keyword interface, and it can include properties such as first name and last name and method declarations as welcome using a function or an arrow function. This example defines an interface. Let's make an object actor that is a type of employee. Now it will bind on the object to define all the properties as specified by the interface. Let's print the values. You can see actor object, actor's first name as Salman and last name as Khan, and welcome, hi there. That's a brief introduction of interfaces. After learning classes, I will explain how to implement an interface. TypeScript also has a concept of classes which was not in plain JavaScript. Basically, TypeScript is object-oriented JavaScript. A class is a blueprint of creating objects. TypeScript introduced classes to avail the benefit of object-oriented techniques like encapsulation and abstraction. The class in TypeScript is compiled to plain JavaScript functions by the TypeScript compiler to work across platforms and browsers. A class can include constructor properties and methods. Let's create a class. Class employee, first name and last name as string, and constructor to initialize the employee first name and last name, and welcome method that will print welcome first name and the last name of an employee. Now we can make an instance of employee class. Let emp1 is equals to new employee with the employee name. Let's console employee's first name and the welcome method. We can see the output, first name as an Angular and welcome method as welcome Angular method. That's the basic idea of class. Just like object-oriented languages such as Java and C#, TypeScript classes can be extended to create new classes with inheritance using the keyword extends. Let's make a new class HR that will extend employee class. This means that the HR class now includes all the members of employee class. The constructor of HR class initializes its own members as well as the parent class properties using a special keyword super. The super keyword is used to call the parent constructor and passes the property values. Basically, when you instantiate a new HR class constructor calls employee class constructor to initialize first name and last name properties. We don't have to repeat it again. We can add method to HR class also. Now I can create a new object of HR class in the same way as created for employee class. Like HR1 is equals to new HR, passing first name and second name. With this HR instance, we can call employee class properties and methods as well as HR properties and methods. We can console the values first name and the welcome method. You can see type as a first name, hi HR from welcome method. That is how inheritance works in TypeScript. A class can implement single or multiple interfaces. Let's see how can we implement an interface. Let's create an interface as a person with a first name, last name and a welcome method. We can declare only properties and methods, and that's the responsibility of the deriving class to define the members. Let's make a class employee that implements person. So you can see we can implement. So you can see the intelligence. The implementing class should strictly define the properties and the function with the same name and data type. If the implement class does not follow the structure, then compiler will show an error. And adding to it, and the implementing class can define extra properties and methods also, but at least it must define all the members of an interface. Let's make an object to instantiate the class. In console the values, you can see the values. You can see the output welcome Salman Khan. I hope you are more clear with the interfaces, and let's move to the last topic, access modifiers. Access modifiers, or you can say data modifiers. There are three types of access modifiers in TypeScript: public, private and protected. By default, all members of a class in TypeScript are public. All the public members can be accessed anywhere without any restrictions. You can notice first name is accessible in employee class as well as employees outside class, as well as its driving class in HR class. And what if you want class members as visible only to that class and not accessible outside the containing class? For that, we have private modifier. If we make first name as private, you can notice it's accessible only in class employee and not outside class employee. You can't access first name outside employee class. You can see property first name is private and only accessible within the class employee. Even in HR class, you can also notice in HR class extending the employee class, we cannot access first name. There are some situations if we want first name to use in derived class, we can make first name as protected. The protected access modifier is similar to the private access modifier, except that protected members can be accessed using their deriving class. Notice, first name can be accessed in HR class but not outside employee and HR class. That is about access modifiers. So we are done with important concepts of TypeScript. If you enjoyed this video, please like and share it with others. Don't forget to subscribe this channel Angular Mentor. Thank you.